Just a minute.
Ma'am,
So today I'm starting.
Thursday means 11th.
Shomodi, why you are disturbing during the class? Earlier also I told you, don't do that. After the class again we will discuss these matters. So last day I completed on the basis of the different axioms, we derived the indifference curve and we stopped here. We stopped here. We consider the commodity space where we consider the two commodity world, and as I mentioned, when I'm considering two commodity world, X2 can be considered as all other commodities as well. So it is not a simply two commodity world, it can be considered in this way too. However, to begin with, we are considering x1 along the horizontal axis and x2 along the vertical axis, and then we divided the commodity space into superior to x zone, inferior to x zone, and the zone of ignorances. And then, first we, with respect to x, we got a point M which is indifferent with x, and then we considered point N which is indifferent with M, then Q which is indifferent with N, and so on. And we talked about a continuous line which can pass from this northwest towards southeast zone. Okay, so it will cover the two zones of ignorance and will give the indifference curve. So I hope you can remember last day we talked about the indifference curve. Since a few students are new, so just to tell you, so this kind of curve we derived last day on the basis of our analysis, a curve starting from northwest, it is coming towards southeast. This kind of curve we derived, and this we called the indifference curve as it is a locus joining all points of indifference. So today I'm starting from this point. Now the way we derived the indifference curve, we felt that it will be a negatively sloped curve because it is coming from northwest towards southeast. So it will be a negatively sloped curve. So indifference curve can be thought of as a boundary line. To the right of the line, we have a set of points which are preferred to the set of points to the left of the line. On the line itself, all points are indifferent to each other. So we did this thing in the last class. Now, today I'm starting from this point. The way we have derived the indifferent curve, or the way we established the line of indifference, or we considered the indifference curve, the line slopes downwards from the left to the right. So we can say that indifference curve will be negatively sloped. Indifference curve will be negatively sloped. It will come from northwest towards the southeast. However, if I consider a negatively sloped curve, it can be a straight line, it can be a convex curve, or it can be a concave curve. Okay, so there are all possibilities. So if I consider a negatively sloped curve, there is a possibility that the curve can be like this. This is also negatively sloped, or we can consider a straight line. This is also negatively sloped. Okay, so at this moment, I am not telling about the curvature of the indifference curve. So I'm putting that the curve may be like this, the curve may be like this, or the curve may be like this. So we will set a limit to the shape of the indifference curve using the axiom of convexity in the preference pattern later. So first, let's understand the idea of the indifference curve and the negative slope of the indifference curve. And then I'll come to the curvature of the indifference curve. And we will limit the curvature to the idea of convexity. In general, the indifference curve will be a convex curve. Okay, and in that context, I'll also talk about the weak convexity as well as strict convexity. It can be strictly convex or it can be weakly convex. Conventionally, whether the curve will be strictly convex or whether the curve will be weakly convex. So we will discuss all these ideas. Before that, I'm considering the axiom 5, which is the axiom of continuity of the preferences. So once we draw the indifference curve, last day we talked about the neighborhood. When we considered this diagram, we told that the gap between W and Y, that is very, very small. Okay, and for that matter, in context of W, we are finding that W is not preferred to X, and at Y, Y is preferred to X. Now, if the gap is very small, definitely there is a point at which the changeover occurs from not preferred to preferred to. So if this gap is very small, in that case, I can have a point in the neighborhood where there is indifference. Then we referred point M, and in the similar fashion, talked about N, then we referred to point N, and again we got a point Q. Okay, so we talked about the neighborhood. We talked about the continuity in the preference. I told that if there is a continuity in the preference, I can draw a continuous line, taking care of all these Q, M, Q, N, M, X, etc. So now I'm going to the axiom of continuity of the preference. So formally, I'm introducing the axiom 5, which is talking about the continuity in the preference. So there exists a set of points on a boundary dividing the commodity space into less preferred and more preferred areas, such that these points are indifferent to each other. For all x prime in the boundary set B of x associated with x, we should have x prime ix. X prime is indifferent with x. So what I am telling that so if this is a particular indifference curve, any point to the right that will be preferred to, any point to the left will be not preferred to, and all the points along the line will be equally likely. So if this point is x and this point is x prime, x, I, x prime. X is indifferent with x prime. Okay, so both the points are equally likely. Both the points are same to the individual. That is, the individual is, if I measure x1 here and x2 here, this amount of x1 and x2 the combinations yeah. Here I should write. This subscript is for the commodity, whereas the superscript is indicating the amounts of x1 and x2. So these 2 points are giving equal satisfaction to the individual. So this is the idea. Okay. So the continuity of the preference is telling this thing. So if I consider any point above the curve, that will be preferred to. Below the curve, not preferred to. Along the curve, all the points are similar to the individual. That is, this combination of 2 commodities x1 and x2 are similar in terms of satisfaction to the consumer if I consider this amount. If I change x1 from 1 to 2 and x2 from 1 to 2, that will also give the similar satisfaction to the individual. Okay, now here I have used a term boundary set. So let's check the definition of the boundary set. A set Bx forms a continuous set of points. This means that if x and x prime are 2 points in the boundary set, then no matter how close together they are, there must be a point between them. Okay, so this is the definition of the boundary set. I told you this starting part of the consumer theory or consumer preference will be based on several set theoretic operations. So last day we talked about the binary relations, we talked about preferred to, identical or indifferent with, and as good as, which we defined by R. So last day we talked about this kind of binary relations based on as good as, indifferent with, and preferred to. And here also we are getting several use of the notions coming from the set theory. So boundary set, I hope you are getting the definition. This is the definition of the boundary set. Now, how I'll present an indifference curve? We are understanding indifference curve will be given by this kind of graph starting from northwest, it will move towards southeast, it will be a negatively sloped line. So that I am understanding. However, the question is how to present it mathematically. Okay, because if I cannot present it mathematically, it will be difficult to talk about the slope of the indifference curve. So we are talking about the slope of the indifference curve. So it is important to understand how mathematically we can present the indifference curve. Now, what is an indifference curve? Indifference curve is giving a series of combination of 2 commodities x1 and x2 for which the satisfaction of the consumer remains unchanged, or the utility of the consumer remains unchanged. We are considering different combination of the 2 commodities, and we are telling that for any combination of x1 and x2 along this line, the consumer will have similar utility. So I can change the combination of the 2 commodities. However, all the combinations belonging to the line will give the similar utility, equal utility, similar or equal satisfaction. So naturally, the equation to the indifference curve can be presented as where C is an arbitrary positive constant. Where C is an arbitrary positive constant. So I'm telling that along the line, if I consider any point anywhere, all these combinations of x1 and x2 will give similar utility. That means along the indifference curve, the utility of the consumer remains constant. Along the indifference curve, the utility remains constant. So mathematically, if I want to capture this idea, it should be presented by an equation given by u of x1, x2 is equal to an arbitrary positive constant, say C. So are you getting the point? Are you understanding how mathematically we can present the equation to the indifference curve? Any question? Anyone? Is it clear to all of you? Yes or no? Yes, please.
Is there any difference between utility and satisfaction?
Would you please repeat your question once again?
Is there any difference between utility and satisfaction?
No. Actually, in context of microeconomics, we consider satisfaction as utility.
Okay, ma'am.
I didn't take your call. Yeah, call me later after the. Yes, satisfaction and utility are similar. Okay, these are same. Actually, we use the term utility in context of microeconomics.
Okay, ma'am.
Now, the equation can be extended if you consider n number of commodities. So it doesn't matter whether you are considering 2 commodities or n number of commodities. So, for the entire commodity bundle, you can fix the equation. Okay, and already I mentioned that X2 is not indicating a single commodity under most of the circumstances. It is actually the bundle of rest of the commodities. Okay, actually X2 in context of microeconomic analysis indicates X minus 1. Okay, rest of the commodities which apart from X1. Okay, rest of the commodities, this is okay, so this is the meaning of X2. So, we can definitely extend the equation for all n commodities. Next, we will come back to the idea of slope of the indifference curve once again. However, before that, I like to introduce the axiom of convexity of the preferences. Okay, so I'll first introduce this and then again I'll come back to the slope and the curvature once again. So convexity of preference, this sixth axiom, is indicating that ICs are usually convex to the origin. ICs are usually convex to the origin. So it is not that never it will be a straight line or it will not be a concave curve. So we will discuss some special cases when the indifference curve may be a straight line, indifference curve may be circular in nature, concave in nature. So these are only the special cases. The axiom of convexity is telling that in general ICs are convex to the origin. Okay, so let's consider this idea. Okay, so let me first discuss the thing here. So please concentrate in this part. Okay, so let's consider in this part. Concentrate in this part. So this is our indifference curve. This is the indifference curve. I'm considering 3 points along the indifference curve, X, Y, and Z. 3 points along the indifference curve. Okay. First, I'm considering a move from X to Y, and then I'll consider a move from Y to Z. Now, as we move from X to Y, from this point to this point, I hope you are understanding I have to reduce my consumption of X2. As I'm moving from this point to this point, I have to reduce my consumption of X2. And I'll be able to increase my consumption of X1. Okay, so what is happening as I'm moving from this point to this point, this amount of X2 I have to leave. I'll be not able to use this amount of X2. I'll be not able to consume this amount of X2. So there is a change given by minus delta X2 because consumption is falling. Delta indicates change, capital delta. This is capital delta. It is indicating change in consumption. And there is a negative change in consumption. Therefore, I have used the negative sign here. At the same time, I'll be able to increase my consumption of X1. Okay, so there is positive delta X1 because I'll be able to increase my consumption of X1. So what actually is happening, I will agree to leave minus delta X2 amount of X2 if we get plus delta X1 amount of X1. If I get this additional amount of X1, I will agree to leave this amount of X2. I will agree to leave this amount if I get this additional amount of X1. Next, I am considering a move from Y to Z. I'm considering a move from Y to Z. Okay. So from this point, I'll move here to point Z, from Y to Z. I'm considering the move in such a way so that I have to leave the same amount of X2 if I like to move from Y to Z. While I'm moving from Y to Z, I am leaving this amount of X2 further. I consider the move in such a way so that minus delta X2 is equal to minus delta X2 prime. The amounts are same. I am reducing the same amount of X2. However, to remain on the same indifference curve, Now I want delta x1 prime amount of x1. Initially, while I sacrificed this amount of x2, I wanted only delta x1 amount of x1. Now, when I am sacrificing x2 further by the same amount, which is given by delta x2 prime and which is equal to delta x2, I want additional delta x1 prime amount of x1, where this delta x1 prime is very, very greater than delta x1. I'm losing same amount of x2 between x and y and z. However, the amount of x1 I need to compensate my loss, that is very, very high here. So what is happening here? When consumer continuously reducing consumption of one commodity, she needs the other commodity more and more to compensate the loss. She needs the other commodity more and more to compensate the loss. Compensate the same loss. To compensate the same loss, she needs more of the commodity. Intuitively, we interpret this using the idea of diminishing marginal utility. Okay, we try to explain this concept, why consumer needs more and more of a commodity while moving from one point to other, that can be explained in terms of diminishing marginal utility. So let me first define what is meant by marginal utility. It is change in utility due to change in consumption by one additional unit. If consumption changes by one additional unit, the total change in utility or satisfaction is given by marginal utility. Marginal utility indicates incremental utility or change in utility. Change in utility due to change in consumption by one additional unit. So what happens in a consumption basket if I continuously increase the consumption of one commodity, reducing the other? In that case, the additional utility we are getting out of consumption of x1, that will continuously fall. So I have, suppose, two commodities in my basket, x1 and x2, or say orange and apple. So if continuously I sacrifice orange and continuously increase the consumption of apple, the satisfaction I am deriving, additional satisfaction I am getting out of consumption of one more apple, that will fall. So I need more and more apples to consumption to compensate the same loss in orange. So to begin with, if I lose one orange, I want 2 more apples. Now, if I want to, or if again drop of 2 oranges or 1 orange is required, I need more than 2 apples. So first I am sacrificing 2 oranges, say, and for that I will want 2 apples. Again, if somebody tells me, give me 2 more oranges, in that case, I need additional 5 apples to compensate this. Because additional utility I am getting out of 1 apple that is continuously falling. So to compensate the same loss, I want more and more of a commodity. This idea is called the diminishing marginal utility. If continuously there is a reduction in consumption of one commodity, the next unit of that commodity becomes very worthy to me. It becomes very valuable to me. And for that matter, we need more of the other commodity to compensate the same loss. Okay, so this is happening here. So when I'm moving from X to Y, I'm losing delta X2 amount. And for that, I want delta X1 amount of X. Next, again, if I have to sacrifice an amount given by delta X2 prime, which is similar to that of delta X2, equal to that of delta X2. In that case, I need more units of X1 because X2 is becoming very valuable to me. Okay, so this is the idea. So let's come back here. So let's consider a move down the indifference curve shown in this diagram from capital X to capital Y. For Y to be indifferent to X, if I want that this point Y should be indifferent to X, as it must be because it is lying on the same indifference curve, the gain of X1, that is delta X1, must exactly compensate the consumer for loss of X2 shown as delta X2 minus of delta X2. Okay, this is the loss. To compensate this loss, I want some additional amount of X1 so that I can remain on the same indifference curve, so that I am indifferent between point X and Y. Okay, so to compensate the loss, I need some amount of X1 more, and that is given by delta X1. The ratio minus delta X2 by delta X1 is referred to as the personal rate of substitution, PRS, of commodity X1 for commodity X2 by Peter Newman in his famous text, The Theory of Exchange. It is also referred to as the rate of commodity substitution, RTS, by Henderson and Quant. More traditionally, we call it marginal rate of substitution. Marginal rate of substitution. So it can be referred to as PRS, personal rate of substitution, because I am substituting some amount of X2 by X1 and remaining on the same indifference curve. It is also referred to as rate of commodity substitution, RTS, or it can be considered as MRS, marginal rate of substitution. This MRS, marginal rate of substitution, indicates the slope of the indifference curve. So the slope of the indifference curve is given by MRS. Okay, So it's better to use a new. This is the marginal rate of commodity substitution minus delta X2 by delta X1. Okay, so if it is a two commodity world, we can write using the standard language of calculus, we can write this as in this way, minus dx2 by dx1. Okay, dx2 by dx1, this is negative by default. So when I am writing minus of dx2 by dx1, this indicates we are considering the absolute slope of the indifference curve. MRS indicates okay, this is the slope of IC, and it is negative because when I am reducing the amount of X2, I need more of X1 to compensate the loss. So conceptually, it is negatively sloped. So if I write MRS is equal to minus of dx2 by dx1, that indicates MRS is the absolute slope of the indifference curve. It is the absolute slope of the indifference curve. Okay, so given the equation, U of x1, x2 is equal to C, we will be able to derive dx2 by dx1 from this equation, and then minus of that dx2 by dx1 will give us the slope or absolute slope of the indifference curve. We can define the marginal rate of substitution in an other way as well. It can be also defined as change in utility due to change in x1 divided by change in utility due to change in x2, del u by del x1 by del u by del x2. It can be presented in this way too. Okay, so this is actually minus dx2 by dx1 when I'll take the derivative from the u function, that will be okay. So this is also called del u by del x1 means change in utility due to change in x1. Now change in utility due to change in consumption by 1 unit is called the marginal utility. So if there is a change in utility due to change in consumption of x1, this is marginal utility of x1. In the denominator, we have del u by del x2. Okay, that is the marginal utility which we are getting from x2. Additional utility we are getting if we increase the consumption of X2 by one additional unit. So it is the marginal utility of X2. So MRS can also be presented as mu x1 by mu x2. This is the ratio of marginal utilities of two commodities x1 and x2. MRS is the ratio of marginal utilities of two commodities x1 and x2. Okay, so this is the slope of the indifference curve. Yes, Amrita. Yes. Class নিচ্ছি I'm sorry, because of some administrative call, I just... Okay, so I'm talking about this, the slope of the indifference curve. It can be presented in this way. So do anyone have any question regarding the slope of the indifference curve, or how we can present the slope of the indifference curve? Any question? Okay, so one more thing we can do here. Now, if I consider the total derivative, if I consider the total derivative of this equation, can you tell me what equation I'll get? Anyone? If I go for total derivative, what I'll get? Shomodeep? If I go for total derivative, what I'll get? Please try.
Ma'am, I can try.
Yeah, please.
Ma'am, minus dx by dx1 equals to 0. So
Would you please repeat?
Ma'am, minus dx2 by dx1 equals to 0. C is 0.
If I take total derivative, totally taking the derivative, total derivative, yes, somebody else will try.
Ma'am, del u by del x1 dot dx1 plus del u by del x2 dot dx2 equal to 0.
So first I am getting this del u by del x1 into dx1 plus del u by del x2 into dx2 is equal to dc.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so everybody is understanding. If I consider the total derivative, are we getting this equation? Del u by del x1 into dx1 plus del u by del x2 into dx2 is equal to dc.
Yes, ma'am.
Okay, then I'm coming here. Okay. And from this, are we getting in DC? C is a constant. So right hand side will be a constant. Okay. So we are getting or we are getting dx2 what we are getting?
Del u by del x1 or del u by del x2.
Are we getting this?
Yes, ma'am.
Everybody is understanding?
Yes, ma'am.
Yes, ma'am.
So in this way, starting from the equation to the indifference curve, we can derive the slope of the indifference curve in this way. This is the starting point, this equation is the starting point. Totally taking derivative, we get del u by del x1 into dx1, etc. Then c is an arbitrary positive constant, so right hand side will be equal to 0. And from there, we are getting minus dx2 by dx1 is the ratio of marginal utilities. Okay. So we are getting this, and this we are calling the MRS, marginal rate of substitution. So the entire thing is same. Minus dx2 by dx1 is equal to mu x1 by mu x2, and this is nothing but the marginal rate of substitution, MRS, marginal rate of substitution. Okay. So this is the idea of the slope of the indifference curve. Okay, next. As you know, when we considered the diagram, we considered del x2 that should be equal to del x2 prime. Already you know this thing. So from the figure, it is evident that a larger amount of x1 is required by the consumer to compensate her loss for x2. The less we have something, the more highly we tend to value the last unit possessed. The absolute value of the slope of the indifference curve becomes, so up to this, I think it's fine. And then I am adding this absolute value of the slope, that is the MRS of the IC, becomes smaller and smaller as we move from the left to the rightward direction along the IC. So now I'm coming to this point. First, I'm defining the slope of the indifference curve, and then I'm telling that the absolute slope of the indifference curve becomes smaller and smaller as we move from the leftward to the rightward direction along the IC. How or why I'm telling so? Now, in the first case, when I'm moving from okay, I need a new one. Okay, when I'm moving from X to Y, I consider the change as this was the change. This is MRS1, say. Then we are moving from Y to Z. We are getting MRS2, say. Okay. So we are getting this. Delta x2 is equal to delta x1. So, sorry. Delta x2 is equal to delta x2 prime. So given this and given this, is the value of the ratio is continuously rising or falling? Consider the absolute value. Consider the absolute value. The numerator is same. The denominator has increased from this. So the ratio is falling or ratio is increasing?
Falling.
So the ratio is falling. So we can say as we move from left to the right along the IC, can we write this line? as we are moving from this towards this, the slope of the indifference curve, is it becoming flatter?
Yes, ma'am.
Yes.
Yes, ma'am.
So as we are moving from left to the right along the indifference curve, the the slope. The slope becomes flatter and flatter. So at y it will be flatter, again at z again it will be flatter. So as we move along the curve from left to right, the slope will become flatter and flatter. Now this is possible, this particular thing is possible if and only if the curve is convex. Now if I consider a concave curve, as we move from this direction to this direction, I hope you are understanding the slope will be steeper and steeper. And if I consider a straight line like this, then the slope remains constant as we move from this point to this point, any point, the slope remains constant. So along a concave curve, the slope increases as we move to the rightward direction, whether for a straight line, the slope remains constant at a particular value as we move to any direction. So only with a convex curve, it is possible that I'll be able to capture this mathematics. Only with a convex curve, I'll be able to capture this mathematics. That is, as we are moving to the rightward direction, the slope is falling. This mathematics I'll be able to capture only with a convex curve. Is it understandable?
Yes, ma'am.
Yes, ma'am.
Okay, so we can say that the indifference curve, the slope of the indifference curve becomes smaller and smaller as we are moving along the curve to the rightward direction. In other words, the indifference curve is convex in nature. The indifference curve is convex in nature. Okay? So, but convexity does not rule out the possibility of completely linear ICs or ICs having linear segment. I hope you know a linear curve is weakly convex as well as weakly concave. Am I right? A linear curve is both weakly convex and concave. Do you know this?
Yes,
Yes,
ma'am.
ma'am.
Okay, so convexity does not rule out the possibility that the curve will be linear. So, to understand the concept well, we are telling that generally the indifference curve will be strictly convex to the origin. Strict convexity assumption we are considering. Strict convexity assumption indicates that any convex combination of the 2 points, say x and y on the ICs, lies above either x or y. Okay, so if I consider an IC, I consider a linear segment joining the 2 points x and y, and consider any point along this line segment that will lie on a higher indifference curve. That will lie on a higher indifference curve. Okay, so this is the meaning of strict convexity of the indifference curve. Next day I'll start from this point, the strict convexity of the indifference curve. So today, just I hope you are getting the idea how we can derive the slope of the indifference curve, what is the meaning of the slope of the indifference curve, and then you are getting some idea. The curve will be not only negatively sloped, it will be convex to the origin, Now, if I consider simply convex curve, it can be a linear one or it can be a curve having a linear segment. That is, if the curve can cut the two axes, so in that case, a part of the axis will also come as the part of the indifference curve. So it will come like this. Okay, so these things are there. So next day I'll start from this point. If you have any question at this point, convexity again I'll explain. Anyone, any question?